Exam 1 review, part 7, question number 28. The area of a sector of a circle with a central angle of 2 pi over 5 radians is 29 miles squared. We need to find the radius of that circle. So we know that the area is equal to half r square theta. We have the area, which is 29 miles squared or square miles equals 1/2 times r squared times theta, which is 2 pi over 5. It really doesn't matter whether you write the pi here or next to the 2 over 5 pi. It's the same thing. So now we need to solve for r. I'm going to do the rest here. So I have 29 equals 1 over 2 r squared over, times 2 pi over 5. And now we're going to multiply everything by 10 because I have the 5 and 2 to get rid of. So now the 10 is going to cancel with 5 and 2, and you will have 290 equals 2 pi r squared. We're going to divide both sides by 2 pi, and we get r squared. So r squared equals 290 over 2 pi, and now r, you take the square root of both sides of the equation because that is positive. We don't care about positive, negative here. So r is equal to square root of the entire thing, 290 over 2 pi. And that is the answer, and that is approximately 6.79 miles. Number 29, are the angles 7 over 6 pi and 27 over pi in radians or coterminal? So in order to find if they are coterminal, we need to see if they happen to be the coterminal side is in the same place. So I'm going to take the 20 pi over 7 and see if I can make it into 6 pi over 7. 6 pi over 7 is basically less than pi, and 20 pi over 7 is basically more than 2 pi. So I'm going to say 20 pi over 7 minus 2 pi, and that is going to give me 20 pi over 7. I need to convert 2 pi into a similar fraction, so I'm going to multiply by 7 and divide by 7. So this turns into 14 pi over 7, which is going to give me 6 pi over 7, and that is exactly the first angle we have. So yes, they are coterminal. Basically, the first one, 6 pi over 7 is approximately here. It's very, very close to, so that is 6 pi over 7. 6 pi over 7. And then we have the other one, which is 20 pi over 7. So it's one full circle and then another one to here. So it's going to be exactly here, but it's like one full circle before you reach that. So it's one revolution and then 6 pi over 7. Number 30, are the angles 84 in degrees and 444 in degrees coterminal? Again, we need to prove that 444, the terminal side is the same as 84 in the first quadrant. So we're going to say 444 minus 360, which is equal to 84 degrees. So yes, they are coterminal for sure. And the question number 31, for each angle below, determine the quadrant in which the terminal side of the angle is found and find the corresponding reference angle. So the angle 4 pi over 3 is basically this is in the third quadrant, so quadrant number 3, and the coterminal angle, the reference angle is going to be, since this is in the third quadrant, so let me just imagine how it looks like. It's going to be approximately here. So that is going to be the reference angle. So we're going to say 4 pi over 3 minus pi. So I'm going to do the math here. 4 pi over 3 minus pi, which I can write as 3 pi over 3, which is going to be pi over 3. So pi over 3 is the coterminal angle in radians. 13 pi over 4 is in the third quadrant again. So this is in quarters, which is easy. So this is pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4, 8 pi over 4, 9 pi over 4, 10, 11, 12, 13. So this is 13 pi over 4. Okay, after some revolutions. So in order to find the reference angle is basically this angle right here, which is going to be pi over 4. That is a quarter, so that is pi over 4. So pi over 4. I'm just going to delete that one. So this is in the third quadrant. And then theta equals negative 5 pi over 6. This is again in the third quadrant. So so it is pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, and then 5 pi over 6. So we can say the same here, but they're negative. So this is negative 5 pi over 6 right here. So now this is negative 5 pi over 6. The coterminal angle, which is this one, is going to be pi over 6. This is basically a third of a quarter. So this is it's in the third quadrant, and it is coterminal to, the reference angle is pi over 6. So I'm going to erase that one. And then we have theta is equal to 6. We need to find the coterminal angle. So this is in radians. We know that 6 in radians. We know that 2 pi is equal to 6.28, which is going to be in the fourth quadrant. So that is in the fourth quadrant, approximately here. And this is all 6 radians. So we're going to say 2 pi minus that 6 radians. So 2 pi is approximately 6.28. So we're going to say 2 pi, which is approximately 6.28 minus 6, which is going to give us 0.28. 0.28, and this is approximate because 2 pi it has a lot of decimals. So that is the answer for that one. Number 32, we need to find an angle between 0 and 2 pi that is coterminal with the given angle. 19 pi over 5. 19 pi over 5 is basically bigger than 2 pi, so we're going to subtract 2 pi from that. So this is similar to saying 19 pi over 5 minus 10 pi over 5, which is equal to 9 pi over 5. That is a coterminal angle. Next question, negative 8 pi over 3 is bigger than 2 pi, so I'm going to add 2 pi to that. So this is going to be negative 8 pi over 3 plus 6 pi over 3, which is equal to negative 2 pi over 3. I will leave it as a negative angle. Now it says it's positive, so I need to make it into a positive angle by adding 2 pi again, which means negative 2 pi over 3 plus 6 pi over 3, and that is equal to 4 pi over 3. So that is the answer. Because it has to be between 0 and 2 pi, so negatives can't count. 65 pi over 2, I'm going to subtract 2 pi from that, so we will get 65 pi over 2 minus 4 pi over 2, and that is equal to, it is equal to 61 pi over 2. Instead of keep removing 2 pi at a time. I am going to remove actually 30 pi at a time. So I'm going to multiply it by 15. I get 30 pi, which is basically a multiple of 2 pi. And then we need that to be equal to 61 pi over 2 minus 30 times 2 is 60 pi over 2, which will give me pi over 2. So that is a coterminal angle. Just because 65 was a big number, I opted to remove multiples of 1 revolution. 19 pi over 11, that is less than 2 pi. So since this is less than 2 pi, it is coterminal to itself. So the coterminal angle is 19 pi over 11 because there isn't a positive angle that is between 0 and 2 pi that is coterminal to 19 pi over 11. But if this was not given to me, I will be able to find the coterminal angle by adding 2 pi to it. But since this has to be between 0 and 2 pi, there isn't such thing, and the only coterminal angle is itself. If t is equal to 0, number 33, if t is equal to 0, then sine t is equal to, we know that sine t is equal to 0, and cosine t is equal to 1. This is basically the unit circle. If you take a look at the unit circle, it is angle 0, and this point is 1 and 0. So sine is 0 and cosine is 1. Here is the angle. If t is equal to pi over 4, here's pi over 4. Here's pi over 4. And this one is square root of 2 over 2 and square root of 2 over 2, and we know that from the pattern. So sine is square root of 2 over 2 and cosine is square root of 2 over 2. If t is equal to pi over 2, here is pi over 2. And we know this point is 0 and 1. So sine is equal to 1 and cosine is equal to 0. If t is equal to 3 pi over 4, so this is 3 pi over 4, is in the second quadrant, 3 pi over 4. And this point right here is equal to, the x is negative square root of negative square root of 2 over 2, and the y is positive square root of 2 over 2. So sine is positive square root of 2 over 2, and cosine is negative square root of 2 over 2. If t is equal to pi, here is the pi, and this point is negative 1 and 0, so sine is equal to 0 and cosine is equal to negative 1. 5 pi over 4 is right here. This is 5 pi over 4. And we know this point, both x and y are negative, so both of them are negative 2 over 2, negative square root of 2 over 2, and cosine is negative square root of 2 over 2. If t is equal to 3 pi over 2, which is basically this point, so this is 3 pi over 2, and we know that point is equal to 0 and negative 1, so sine is negative 1 and cosine is 0. 7 pi over 4 is here. So this is 7 pi over 4, and we know that point x is positive and y is negative. So sine is negative square root of 2 over 2, and cosine is square root of 2 over 2. Remember, this is cosine and sine, so we read it like that. So x is cosine and y is sine. Find the coordinates of a point on a circle with a radius 30 corresponding to an angle 80 degrees. So now I'm going to try to draw it in the first quadrant. Okay, so here is the point. Here is x and y, which means this is basically y, and this is x, and this is 80 degrees. And the radius, which is the hypotenuse, is 30. So now we're going to use the trig ratios to figure these out. So we're going to say that sine 80 degrees is equal to opposite over hypotenuse, y over 30 degrees, not degrees. So now we're going to multiply both sides by 30, which means y equals 30 times sine 80 degrees. We're gonna make our calculator in degree mode, make sure it's in degree mode, and we're gonna say 30 sine 80, sorry. And that is gonna give me y equals to 29.544. And then we say that cosine 80 degrees is equal to the adjacent over hypotenuse. We're going to multiply both sides by 30. We get here x equals 30 times cosine 80, which is again 30 times cosine 80 is equal to 5.209. So that is the answer for question. So the 2 points are going to be 5.209 and 29.544. Question number 35. We have C equals 4, A equals 2. We have, this is a right triangle. We need to solve that triangle. So the first step, we're going to find B using the Pythagorean theorem. We know that C squared is equal to A squared plus B squared. So that means 4 squared is equal to 2 squared plus B squared. And that means 16 equals 4 plus b squared. We solve for b, so we subtract 4 from both sides of the equation. We get 12 equals b squared, which will make b equals to square root of 12. So that is equal to square root of 12. And now, so that is b equals square root of 12. To find a, angle A, we're going to say sine A is equal to the opposite over the hypotenuse, which means that A is equal to the inverse sine of 2 over 4. Basically, what we did here, we took the we took the inverse sine for both sides of the equation. So what we're going to do here, let me actually write it out, of sine A equals inverse sine of 2 over 4. So we took inverse sine for both sides of the equation. Again, I told you that technically it's not that way, but I'm going to write it that way so you can understand it. Inverse sine of 2 over 4. And then we make sure we are in degree mode, and then we do second sine, and then 2 over 4, which is 30 degrees. So that is 30 degrees. A is 30 degrees. Since A is 30 degrees, we can compute B 60 degrees because they have to add up to 90 degrees. So 30 degrees and 60 degrees. Question number 36. Again, here is a triangle and we need to compute all of the trig ratios. This question, you will not need a calculator for it. So without a calculator, find all of the trig ratios. Don't answer to do decimals, just put the actual answer or the exact answer. So we have side B is 7 and we have side A is equal to 12, which means to find C, we're going to use the Pythagorean theorem. So C squared equals A squared plus B squared. C squared equals 12 squared plus 7 squared. C squared is equal to 144 plus 49. And C squared equals to 139. 193, that's what I meant. 139. How did I come up with that? I meant C squared is equal to 193. And C equals to square root of 193. So I'm just going to leave it like that. This is square root of 193. I'm going to leave it like that. Sine A is opposite over hypotenuse, so 12 over square root of 193. I'm going to rationalize by multiplying by square root of 193 over square root of 193. That will give me 12 root 193 over 193. Cosine A is adjacent over hypotenuse, so that is 7 over root of 193. Rationalize, multiply by root 193 over root 193. You get 7 square root of 193 divided by 193. Tangent is opposite over adjacent, so that is 12 over 7. Secant is the reciprocal of cosine, so I'm just going to reciprocate the first part here. It's easier, so this is square root of 193 over 7. Cosecant is the reciprocal of sine. Again, I'm going to reciprocate the first part here before the rationalization. It's easier, so it's going to be root 193 over 12. And then cotangent is the reciprocal of tangent, which is 7 over 12. Number 37, this question requires a calculator, so you cannot skip that part. The proper angle for a ladder is about 75 from the ground, 75 degrees from the ground. Suppose you have a 12-foot ladder. How far from the house should you place the base of the ladder? So we need to find this distance right here. I'm going to call that x. We know that the x is adjacent to the angle, so we're going to say cosine 75 degrees is equal to the adjacent over hypotenuse. I'm going to multiply both sides by 12. These will cancel. You will have x is equal to 12 cosine 75 degrees.
And I'm going to say 12 times cosine 75 degrees.
And that is about 3.11 feet. So it should be about 3.11 feet from the house if we want to put it at the proper angle. Find the area of the triangle below. So we know that the area of the triangle is half the base times the height. So we need to find the base and the height. We were given the base, which is 5, and now we need to find the height. So I'm going to call the height y in this case, and I know this angle is 50. Relative to the angle given, we have the opposite and we have the hypotenuse, so we're going to use tangent. Tangent 50 is equal to the opposite over the hypotenuse. I'm going to multiply both sides by 5. So I will have y equals to 5 tangent 50 degrees. So y equals to 5.95, 96. So the area is equal to 1/2 times 5 times 5.96. So 88.79 units square, or square units.